Good afternoon. Welcome to lesson 2 on the topic of discriminant. Now in lesson 1, you learn about discriminant. For now, we will do 2 more examples so that you are more familiar with the application of discriminant. Let's start with example 1. Now in example 1, you are given this expression you are asked to find the range of values of k so that this is always greater than 0. Now, before we do anything, let us expand this and put it in the form of a squared plus ax squared plus bx plus c. So you expand this, you will get kx squared plus 2kx plus 3k minus 4x minus 2 is greater than 0. Now we put all the x together and we factorize the x out. So this will be 2k minus 4 into x plus 3k minus 2. Alright. Now, if you want this to be always greater than 0, your k, your condition 1, k must be greater than 0. Now, why is this so? Now, if k is greater than 0, then let me use a different color. Now, if k is greater than 0, the shape of your graph is this way. Now, you want it to be always positive, so this minimum point must be above the x-axis. Now, what happens if k is smaller than 0? The shape of your graph will be this way. And you want it to be always positive. So it's impossible. Some of you may think that, oh, this is your x-axis. Now, your graph, not forgetting your graph is continuous. Alright? Because it's for all values of x, so it's continuous. So is this. So you find that this graph is sometimes above 0 and sometimes below 0. So it is impossible if k is smaller than 0. Now, but if k is greater than 0, it can be of this shape too. But this is not what we want. This is what we want. Now, we want it not to cut the x-axis because it is always greater than 0. Now, if it is always greater than 0, implies that it has no roots. Now, for a quadratic equation to have no roots, your b squared minus 4ac, that is your discriminant, must always be less than 0. So, condition number 2. Your discriminant must always be less than 0. Must be less than 0. So, let's work out what is a discriminant. So, b squared. So, 2k minus 4 squared minus 4, a is k, c is 3k minus 2. Must always be less than 0. So this is for no roots. For no roots. Let me expand this. So you got 4k squared plus 16 minus 16k minus 12k minus 12k squared, and this I will have plus 8k is smaller than 0. Now these are two like terms, so I get minus 8k squared. This and this are like term, so minus 8k plus 16 is smaller than 0. Now I bring the 8k squared over to the other side, and I bring everything to the other side because I'm more familiar, I'm more comfortable to factorize if the x squared is positive. So it will be 8k squared plus 8k minus 16 greater than 0. Okay, now I will do it here. Now everything divide by 8, so you have k squared plus k minus 2 is greater than 0. Now let's factorize this. You got k plus 2 into k minus 1 greater than 0. Now how to solve this quadratic inequality? You have learned it, all right, in earlier. Now let me sketch this out. Now this will be minus 2. It has one of the roots is minus 2 and the other roots is 1. This is a positive x squared, so the graph will look something like that. Alright, this point here is minus 2. Okay, now you want it to be greater than 0. So it is this part of the graph that you want. Alright, it is this part. So the value of x you should take is this part. Because these are the values of x when you substitute in, or k, when you substitute into this expression. You will find that this expression is greater than 0. Okay? Now, so your values of k will be, therefore, k must be smaller than minus 2 or k greater than 1. Now, this is not your final solution. Now, your final solution, you must satisfy your condition 1 as well, because this is an AND condition. You must satisfy both conditions because you want it, you does not want the graph, you want the graph to be always above the x-axis. So it must not have roots. And the other condition is the shape of the graph must be this. So k must be greater than 0. Now, so if we draw a number line, now this is 1, this is minus 2. So this is less than minus 2, and this is greater than 1. But what is the earlier condition? K must be greater than 0. So the other one is k greater than 0. So you must satisfy the top condition and the bottom condition. So this is the values of x that you want. So your final answer is just k. No, sorry, your final answer is k must be greater than 1. Okay, so this is your answer. This one we reject. For that, we have come to the end of question 1. We will move on to question number 2. We come to question 2. In question 2, you are asked to show that 10x squared minus 6mx plus x squared plus 1 equals to 0 has no real roots for all values of m. Let us first write down the equation first. So you have 10x squared minus 6mx plus m squared plus 1 is equals to 0. Now, if there are no real roots, what is the condition? All right. So for no real roots, your discriminant must be less than 0. Okay? No, so let's find out what is the discriminant. So the discriminant will be b squared. So what is b squared? Is 36m squared. Square of minus 6m, you square it, you got 36m squared. Minus 4. A is 10. C is m squared plus 1. Now you expand this out, you get 36 m squared minus 40 m squared minus 40. Now a lot of students, alright, at the beginning they will write this is less than 0. No, that is wrong, because you are supposed to show that this is less than 0 for all real values of m. Now, so by writing this means you are assuming that it's less than 0. They are asking you to prove, because they ask you to prove that there's no real roots. If there's no real roots, that means the discriminant is less than 0. So you need to prove that the discriminant is less than 0. So you cannot write this statement less than 0. You are supposed to prove. Okay? Now, so we expand it out, you get this. Let's simplify. Then you got minus 4m squared minus 40. Now, since, let me use a different ink, it's easier, different color. Now, since m squared is greater than or equals to 0, then implies minus 4m squared is smaller than or equals to 0. Because you times a negative 4, you must flip the sign. Alright? So therefore, minus 4m squared minus 40 will be smaller than or equals to minus 40, which implies that this is less than 0. Alright, because 0 is greater than minus 40. Alright, so we proven. Alright, you may want to add a statement. Alright, therefore, or since discriminant is less than 0 for all values of m, implies that 10x squared minus 6mx plus m squared plus 1 equals to 0 has no real roots. Okay? That's the end of today's lesson. Thank you very much and have a nice day.